Hello my class, I'm Devanshudev, trying some classroom situation for you during the lockdown period with lots of lessons, animations, virtual practicals and related notes. Please subscribe to my blog, Expositate, to remain in touch with me. Thank you.
Good evening students. This video I'm making for some of my class 9 students who has approached me so that I can prepare a video to guide them. In fact, the class 9 syllabus has got many parts, like as many as 5 parts. Amongst them, physics, chemistry and biology is there. The first chapter is the first unit is matter and its nature and behavior, which is basically chemistry, and 23 marks are there. Then living world. Let's begin with a straight line graph. This sort of graph is called a straight line graph, and the equation it represents is called a linear equation. The points are where the graph crosses the x-axis and y-axis are called respectively x-intercept and y-intercept. I'll come to this point, but maybe you have to first see if there is a equation like y is equal to x, then what will be the shape of the graph. This green colored graph you can see that is passing through the origin and it has got a slope of 45 degree. What is slope? In fact, slope is tan 45 degree. The tan 45 degree equal to 1. Slope means the tan of angle made by the graph with the x-axis here. So let us say y is equal to minus x, then what will be the shape of the graph? This y is equal to minus x is the other way. Here the slope of the graph is in the negative direction and it will be 180 degree minus 45 degree. Now let's do something more about it. This is a graph. Y is equal to mx plus c. This m is known as the slope. We have got m is equal to 2 by 3 here. Let's increase the denominator, that means 2 by 4 say. 2 by 4, now you can see the slope of the graph has decreased. 2 by 4 is 0.5. Even more, 2 by 5, it is even flatter. 2 by 6, 2 by 7, 2 by 8, like this. Or you can reduce the denominator to see that the angle is increasing. Here we can see plus 2, it may be 3. The earlier 3 by 5 and 2 by 5 I have shown for your reference. The earlier 2 by 5 and now it is 4 by 5. Now if it is 5 by 5, exactly the one I was talking about. This 1, the 1 is known as the y-intercept. We can increase or decrease. Let's see, this is violet color, the pink color point you watch. If I increase this 2, 3, 4, you can see the pink color pointer going up. And if it is decreasing, so still the slope of the graph remains the same. Even it can be minus. You can see the minus side. So the pink color point is moving to the y-axis point. There is another part of the graph, that is the slope, but in my subsequent lesson I will be talking about the difference of slope. My previous lesson I talked about the slope. This is the slope m is equal to y2 minus y1. What is y2 and what is y1? y1 is one point which is corresponding to the value of x1 in the x-axis, and y2 is a point on the y-axis, the reference point on the y-axis, when the corresponding value of x is x2. Now let us have some values to explore. M equal to, say, here it is given as 4 minus 2 divided by 3 minus 1. That is, the slope is 2 by 2 equal to 1. Now if I say increase the numerator, you can see 4 minus 3 is 1. So the slope has become half of the previous one. Or you say, I have taken 4 minus 4 divided by 3 minus 1. So the slope has become 0. 0 is, it is a parallel line to the x-axis. Now let us make it minus. Now this becomes minus 0.5. This is called a negative slope. The negative slope will increase with the numerical value. This is having a minus 1045 degree slope here. So this is another type of question that is important. This is little more complicated expression. That is, instead of y is equal to mx plus c, we have taken y minus y1 is equal to m into x minus x1. The m is still the slope. But this case, the interesting part is y minus y1. There is a y1 point. Let us see what is the meaning of y1. Now I am increasing y1. If I am increasing y1, what you see? That value is in such a way that it is gradually going up the y-axis, or you can decrease it. You can understand? This is the meaning. Now let us see what about m. If I change the m, the 4 by 4 is 45 degrees. So once again 45 degree. And what about x? Minus 1, minus 2, x minus 2, that's x minus x1. This value you are changing. So when you make it x minus 5, that is, in this case, it is passing through the origin. So the intercept is different. Intercept has got 0 value there. Now I increase x1 to minus 6. Minus 6 is, so you can see the x-intercept has become little more than 0. But the y-intercept is minus 1. So this is an interesting aspect of the graph, where the size of the object is much smaller, negligibly smaller than the size of the path. So let us see. So in mechanics, a particle is a geometrical mass point or material body of negligible dimension. It is only a mathematical idealization. Actually, it doesn't exist. Before I go for the example, let me tell you one thing, that at the beginning part of your physics lessons, we'll be taking a body. So whenever I say a body, you'll understand that it is a point object. So the first example is a ball, a car, an aeroplane, and a ship. Do you think they are point objects? A ball in your hand may not be a point object, but when this comes to the entire size of the stadium, say Melbourne's cricket ground, in that size of the ball is much smaller. So in that case, it's a point object. So it's a relative point. A ship or an aeroplane or car, there's no way they are point objects, but when I take the entire earth into consideration, they are point objects because their size is so small that their path is much bigger size than the size of the object. So nearest approach to a particle is a body whose size is much smaller than the distance or the length measurement involved. So the next point is motion and rest. We all are knowing what is motion and what is rest, but remember this is also a relative term. Why I'm telling relative, you will understand here. Say a ball, a car, they are stationary with respect to a man on the earth. Now ball is at rest with respect to the stationary man, the car is at rest with respect to a stationary man. Now the ball moves, the ball is moving with respect to a stationary man. The car starts moving, it is at motion in with respect to the man. But the things are not same always. And object is said to be in motion if it changes its position with respect to its surrounding and with time. That is known as motion. So it's the most comprehensive definition I could gather these days. Some example: moving car, buses, trains, cricket ball, etc. These are moving objects. All the planets revolving around the sun, these are moving. Molecules of a gas in motion above 0 Kelvin. Remember, at 0 Kelvin there are some strange thing happening that you will be learning in a thermodynamics chapter, but at present you can understand that above 0 Kelvin the molecules are in motion. And what are at rest? An object is said to be rest if it doesn't change its position with respect to its surrounding and with time. Example: mountains, buildings. Okay, let me ask you one thing. Are the mountains stationary? Are they at rest? Well, you might be thinking it's a funny question, but let me tell you. What about the earth? They are at the same position, means rest, with respect to the earth. But the earth around the sun is moving at a speed. Can you guess? It is 31 kilometers per second. Well, 31 kilometers per second is not a small speed. So with such a high speed, the earth is moving around the sun. So this is the same velocity that has been imparted to the mountains and buildings also. So they are not at rest with respect to a stationary observer in the deep space. Well, just little crazy thinking. Rest and motion are relative terms, that is the point. So an object which is at rest can also be in motion simultaneously. So a body at rest and a body in motion, that can even occur simultaneously. Say you are sitting in a bus and there is a co-passenger sitting with your next seat and you are talking. Are you in rest or in motion? Actually, you are not changing your position with respect to each other. If the road is some better roads, so you will not be falling down or like moving, shaking. So in that case, you people both are at rest. But when they are observed by someone at a bus stop, they'll see that along with the bus you are also moving. So it depends on who is watching. Now let's see, motion and rest are relative terms. There are some animations for it. A person, stationary person, is standing on the ground, and we are not taking into consideration the movement of the earth. A car moving with respect to a stationary man. Another car that is moving with respect to a stationary man. Well, that's a man moving with respect to the stationary man. Now let's see what happens there. Now both of the cars are moving. Both of the cars are at rest with respect to the stationary man initially, but when they are moving at the same speed, both the cars are at rest with respect to each other, but the man, he says that both the cars are moving. Motion and rest are relative terms. That was the velocity I was talking about. The earth is revolving around the sun in a circular orbit, nearly circular orbit, and it is moving at a speed of, at an instant, its speed is nearly about 31 km per second. Anyway, its velocity changes from time to time. This is not a point to be discussed right now. The example of motion of ball, car, man is considered to be at rest, but the man is standing on the earth, and the earth itself moves around the sun as well as rotates about its own axis. So they are not stationary in that purview. Therefore, man is at rest with respect to the earth, but is rotating, revolving around the sun. That is why motion and rest are relative terms. Now, once again, let me start with that concept of shape. The shape is moving from one port to another. Okay. Then another motion example is this is you can say the universe, like the Milky Way I'm talking about. The Milky Way is also revolving around its own axis. So there is an axis at the nearly at the center where there are 4 black holes, for your information. So man A with respect to man B. So can you understand they are at motion A or motion B? Rest or motion, man A and man B. Man A with respect to the ship, man B with respect to the ship, ship with respect to still water, man A with respect to still water, man B with respect to the still water, ocean with respect to the earth. There are some more. Ocean with respect to the sun, earth with respect to the sun. So these a few case studies you can write down in your copy and find what is the correlation. So I have talked about some 12 cases here, so you should be imagining about it. Then another point is the graphical analysis. The graphical analysis is a very important thing. At the beginning I talked about some of the graph plotting techniques. Now here you have to understand that how the graph should be drawn for a motion. But for that, a reference point has to be taken into consideration at the origin. Usually, I'm telling you, it is usually, the reference point is taken where the time starts t equal to 0. Time starts means this is as if a stopwatch being started. We can use any object as reference point. For example, car at rest or in motion can be used as a reference point. It can be like you're traveling a bus or train, so you can take any corner of the car, bus, or the train as the reference point, or yourself can be also a reference point. So these are some cases you can understand. So to a tree you are moving forward, and to you the trees are moving backward. Very interesting, right? Both you and the trees can serve as a reference point, but the motion cannot be described without reference point. What effect do you get when you play video game involving car racing? Okay, when you are playing a video game, you'll see that the like it is stationary. The car you are driving in the video game is stationary with respect to you, but it is moving with respect to other cars, and the audience usually audience simulation is given, so they are moving backward. Motion in a straight line. The motion of a body may take place in one dimension, that is called 1D, along the straight line. This can be represented graphically by plotting a graph between the position of the body and the time taken by it. This is called position time graph. Origin, unit, and direction of position of measurement of an object. So let me show you what I mean here. The O position, that is the origin, and maybe in kilometer, 10, 20, 30, 40, 50 kilometer, and this is along x-axis, and minus axis minus 10, minus 20, minus 30, like this. The distance measured to the right of the origin position is positive, and to the left is known as negative. The origin for position can be shifted to any point on the position of the axis. Now it is at 0, it can be later on taken at 10, plus 10, or minus 10, or minus 20, like that. The distance between 2 points on position axis is not affected due to the shift of the origin of the position axis. This is a very interesting thing, but it will require some more understanding about the axis, so I'll describe it a bit later. So origin, unit, and sense of passage of time. Remember, in this type of situation, time is also a variable. So we have taken time in hours. So time can be positive and negative. This is a very interesting thing. So time can be negative also. Time negative means you are going back, like maybe it's yesterday or day before yesterday. That is the negative time. Or in other words, you can say that just before the moment when you have started the stopwatch. The stopwatch is the best understanding about the time axis. The time measured to the right of the origin of the time axis is taken as positive, and time measured to the left of the origin is taken as negative. The origin of the time axis can be shifted to any point on the time axis. So you can take the time may start from at any instant. Let's say you reach the school at 7:20. So at 7:20 you can take the stopwatch starting, and maybe at 7:50 your or 7:55 rather, your assembly is over. So 7:55 may be represented as maybe 7:55 minus 20 is 35 minutes. So 35 may be plotted in the t-axis. The negative time coordinate of a point on time axis means the object reached that point a time that much before the origin of the time axis. Let us see. So you reached 7:20 at 7:20 a.m. but you got up at say maybe 6 o'clock, 6 a.m. So in that case, your time axis starts at 7:20, but it is minus 1 hour 20 minutes That is the at the time when you got up. The time interval between 2 points on the time axis is not affected due to the shift of origin of time axis. Anyway, the distance difference of between two intervals, okay, it is called interval, or two events, doesn't depend on the shift of origin of time axis. When the same point is chosen as origin for position and time, then what happens? Let's see. So x equal to 0 kilometer and t equal to 0 hour taken as the origin, and we are now not taking the minus axis. So at 6 hour you have reached 30 kilometer away. That may be by cycling, it is very much possible to move 5 kilometer an hour. So that is, you have cycled. After 8 hours you have reached at a distance of 40 kilometer. So that is another C point you have reached at t equal to 11 hour 55 kilometer. When the different points are chosen as origin for position and time, then what you will see, x equal to minus 40 kilometer, t equal to minus 6 hour. When it is, when you take A as the origin. Do you understand? So that way you can take different origin for different time. Okay, origin you can change, and that way the event position may also change. Now, what is distance? Distance traveled by a body is actual length of the path covered by the irrespective of direction in which the body travels. So the north side, a person is walking. So if it is north, then the x-axis, the direction along which the person is moving, it will be in the east. Remember here, there may be an oblique direction shown, but it is not oblique because of the problem of turning the man animation. So that's why I meant it is north. Okay, so the oblique direction 2 kilometer, that is north, and 5 kilometer along east. So what is the total distance traveled? The total distance traveled is 5 kilometer plus 2 kilometer, that is 7 kilometer. Now let us see another case, that is the man is moving 5 kilometer towards east and then west 5 kilometer. What is the total distance traveled? The total distance traveled will be 10 kilometer. There is another aspect that is called displacement. Displacement is a vector quantity. Distance is a scalar quantity, but displacement is a vector quantity. So displacement of a body is the shortest straight line distance between its initial position and the final position along with direction. So once again, the earlier case, let us observe. So the man goes 5 kilometer towards east and 2 kilometer towards north. The total distance traveled is 7 kilometer, but the displacement is root over 5 square plus 2 square, that is 6.57 kilometer. With the direction along the direction it is shown by the arrow. Now let's see, if the person goes 5 kilometer towards east and then again coming back west, so this will be 0. The displacement would be 0. The next one, that's a ball moving like this, and the distance traveled is ACB, but what is the displacement? Displacement is AB, direct straight line. Conclusion about displacement. The displacement is a vector quantity. Displacement has units of length. Displacement of an object in a given time interval can be positive, 0 or negative. The actual distance traveled by an object in a given time interval can be equal to or greater than the magnitude of the displacement. The displacement of an object between 2 points doesn't tell exactly how the object actually moved between two points. Let me tell you a very funny example. Say you are cycling in a circular path and you take 5 minutes to complete the circular path, maybe a park. Now after 5 minutes your displacement will be equal to 2 pi into r. R is the radius of the path, but displacement equal to 0. So after say 2.5 minutes you will be in the other side of the park, so that will be the diameter, twice r of the displacement will be twice r, but the distance is pi into r. The displacement of a particle between 2 points is a unique path which can take particle from its initial to final position, that is the displacement. And the displacement of an object is not affected due to the shift of an origin of the position axis. In every case it is seen that when we change the origin, it is not going to change, either it is time or the distance, or even the position. Actually position changes, but distance displacement doesn't change. So some comparative analysis of distance and displacement. Distance is a scalar quantity. Scalar quantity is one which doesn't depend on either any distance direction. It is only the magnitude. Magnitude means its numerical value. And displacement is a vector quantity. That means it depends on the magnitude, that is the numerical value, as well as the direction. Number 2, distance traveling. The distance traveled by a moving body cannot be 0. So if a body changes its position, then its displacement can be 0, but distance cannot be 0. Can you guess what example I told you? That is the circular path one. Yes, right, you likely guess. So what is scalar? Scalar quantity is a physical quantity which has magnitude only. Length, mass, time, speed, energy. These are scalar quantities. Very interesting thing. I told time has a direction. So can it be called a vector? Answer is no. There are even some more examples. The current. Current is a scalar quantity, though it has a direction. So direction has got some exclusions. I will talk about in your higher classes, not now. And the vector quantity is a physical quantity which has both magnitude as well as direction. So its direction is important. So displacement, velocity, acceleration, momentum, force, these are vector quantities. Now actually the physical quantity is one which we can measure. Like physical quantity is a quantity which can be measured and expressed in magnitude. That is called physical quantity. But is there any non-physical quantity? Oh yes, non-physical quantities are also there. Say you see a small kid and say that, oh my god, this is such a wonderful, I love him so much. So much means how much? So it's a non-physical quantity. The emotions you cannot find out. It's a non-physical quantity. I hate him like anything, but what is that part? Anything. That anything cannot be measured. So that is actually a non-physical quantity. Length can be measured and expressed. So that is, length is a physical quantity. Mass can be, relative density can be. These are all physical quantity. It is not necessary that physical quantity should always have some unit. Its unit may be different also. let me talk about the speed. Speed is defined as the time rate of change of distance of a body, or you can say speed is defined as the distance traveled by a body per unit time. That unit time may be second, it can be minute, it can be hour, like this. So speed is equal to distance traveled by time. If a body travels a distance of s in time t, then the speed v is given by v is equal to s by t. Some of the books, they use s for speed, but I will prefer to use v is equal to s by t. S is the distance. Speed is a scalar quantity. Speed is either positive or zero, but never negative. Speed of a running car is measured by speedometer or avometer, and speed is measured in meter per second, centimeter per second, foot per second, kilometer per hour. So unit of distance by unit of time. Uniform speed. A body has a uniform speed if it travels equal distances in equal interval of time, no matter how small this time interval may be. So you can see it's a uniform speed because the car is moving through in such a way that it is moving through an equal distance in equal interval of time. It's a uniform motion. A body has a uniform motion if it travels equal distance in equal intervals of time, no matter how small this time interval may be. Variable speed. A body is said to be moving at variable speed if it covers unequal distances in equal interval of time, however small this time interval may be. Non-uniform motion. A body has a non-uniform motion if it travels unequal distances in equal interval of time. The time you can change the distance only. The time axis is remaining the same. So one example of non-uniform motion: a car, driving, starts, stops, accelerates. These are non-uniform motion. Average speed. Average speed of a body is the ratio of total distance traveled to the total time taken to cover this distance. Average speed is total distance by total time. Remember, even if you have a number of speeds given, you cannot average to find out its average speed. You have to use only one formula, that is total distance by total time. Let a car covers, one example I'm giving, let a car covers first 25 km in 1 hour. So you can say the speed is 25 km per hour. Next 35 km in half hour. So what will be the speed for that instant? For that interval, it will be 70 km per hour. And last 30 km in 1 hour. Then will you take 25 plus 70 plus 30? Answer is no. Then you have to take the average speed as, first you add all the distances, 25, 35 and 30, divided by total time, 1 hour plus half hour plus 1 hour. The answer comes out to be 36 km per hour. Instantaneous speed. When a body is moving with a variable speed, the speed of the body at an instant is called instantaneous speed. The car speedometer shows you the instantaneous speed. Velocity. Velocity is defined as the time rate of change of displacement of a body, or velocity is defined as the distance traveled by a body in unit time in a given direction. So distance traveled in a given direction by time is known as displacement. By time is called velocity. If a body travels distance s in time t in a given direction, then the velocity v is given by v is equal to s by t. In your higher classes, we'll be having some even more comprehensive symbols there. So there v is called either del s by del t or ds by dt, or it is called ds dt. But the idea of limit is not there for you, so that's why I'm still using v is equal to s by t. You can give because v equal to s by t is same for velocity as well as for speed. So you can take a small bar above the velocity, an arrow that will show that it's a velocity. Velocity is a vector quantity. Direction of velocity is the same as the direction of displacement of the body. Velocity can be either positive, 0 or negative. Velocity can be changed in two ways: by changing the speed of the body, or by keeping the speed constant but changing the direction. So even the direction changes velocity. Both the speed and velocity has the same unit system. Depending on the unit system, that is centimeter per second, meter per second, or kilometer per hour. In practical life, we take it kilometer per hour, because centimeter per second uh, is a small distance involved. Uniform velocity, where body is said to be moving in uniform velocity, which travels specific direction in a straight line and moves over equal distance in equal interval of times, no matter how small this time interval may be. No effort or force is required to move the body with uniform velocity. So when effort or a force is given, the velocity changes, so, and that it is called an accelerated motion. Then variable velocity, a body is said to be moving with variable velocity if its speed or its direction or both changes with time. Average velocity, just like average speed, it is the total displacement by total time taken. Sometimes this is written as initial velocity plus final velocity by 2, though it's not always true. U plus b, it can be sometimes given. Instantaneous velocity, a body is moving with variable velocity. The velocity of the body at any instant is called instantaneous velocity. As I told you, that as it is measured in the car speedometer. Difference between speed and velocity. Speed and velocity. Speed is the time rate of change of distance. Velocity, time rate of change of displacement. Speed tells nothing about the direction of motion of the body. Velocity is the direction of the body. Speed is a scalar quantity. Velocity is a vector quantity. Speed of the body can be positive or 0. Velocity of the body can be positive, 0 or negative. Negative also, no? So average speed of a moving body can never be 0, but average velocity of a moving body can be 0. Can you guess the example? Yes, that is the rotational circular path I told you, the POC. Acceleration. Acceleration is defined as the time rate of change of this velocity. So acceleration, change in velocity by time taken. So acceleration is the final velocity minus initial velocity by time taken. Suppose a body is moving with initial velocity u changes to final velocity v in time t, then a is equal to v minus u by t. Acceleration is a vector quantity. Direction of acceleration is same as the direction of change of velocity, and acceleration can be either positive, 0 or negative. 0 acceleration means the body is moving in a uniform velocity, and negative acceleration means the body is decelerating or retarding. Acceleration is measured in centimeter per second square, meter per second square, kilometer per hour square. Uniform acceleration, a body is said to be moving with uniform acceleration if it travels in a straight line and its velocity increases by equal amount in equal interval of time. Or a body has uniform acceleration if its velocity changes at uniform rate. Some example: the motion of a freely falling body is uniformly accelerated motion. For small heights, maybe a few 100 kilometer, it will not be equal. So let's see one example. I love this type of animations. Okay, that's an uniformly acceleration. The motion of a sliding block on a smooth inclined plane is uniformly accelerated motion. Okay, if you remove it, it falls. It's a uniform acceleration. Of course, the acceleration will not be equal to acceleration due to gravity. It will be a component of acceleration due to gravity. That component part also you'll be later on learning about. Non-uniform acceleration. So as you understand, that is just the other way. That is, a body is said to be with non-uniform acceleration if its velocity increases by unequal amount in equal interval of time. The real-time car movement, it's a non-uniform acceleration. And if it is a rush driving, then it is even more non-uniform. You can see, okay, this car accelerating, decelerating, moving uniformly. So this is a non-uniform acceleration. Retardation or deceleration or negative acceleration. What is said to be retarded if its velocity decreases with respect to time? So you can understand this one is acceleration in backward direction. Graphical representation of motion. It's a time axis in the x-axis, distance in the y-axis. So this is a uniform motion, equal distance in equal interval of time. The position by dropping some perpendiculars, it's called intercepts. You can get the instant, the time, and the position. Speed is equal to AB upon OB. That is also called the slope. I talked about slope. Speed time graph, that is uniform speed I'm talking about. So the speed is not changing with time. So what will be the shape of the graph? Graph will be a parallel line because the value of speed is not changing. Now let's see speed time graph of the speed time is one is AB and another is C, that is D. Then area of the speed time graph indicates distance traveled. It's an important concept that from the speed time graph we can also find out the distance. How? By taking the area, two intervals you take, and the area here will be giving you the distance. So here the area of ABCD is the distance traveled between T1 and T2. Non-uniform motion. Non-uniform motion is when the body is accelerated uniformly or non-uniformly. So it is a non-uniform speed but uniformly accelerated. It is a distance versus time graph. Distance time graph of uniform retardation. Here the speed is decreasing with time. So the shape is like this. Non-uniform speed, both of them are non-uniform speed. Speed velocity versus time graph, uniform acceleration. Now velocity time graph is always a better option to study the motion. So it is okay. I can draw the graph, and even now the acceleration you can find out by taking the slope. What is slope? Slope is the perpendicular by the base AB upon OB. It's a geometrical thing, and this is later on you'll be learning. This is called in class 10. You'll be learning about trigonometric concept. In that you'll be learning about tan theta. So the this slope of the graph is called tan theta. and its area gives us the distance traveled. So uniformly retarded body, okay, same way can continue. So yeah, AOB is the distance. Now it is the velocity time graph when initial speed is not zero. The initial speed, the point C, that is also known as initial velocity. It is sometimes written as U or V within bracket 0. And this is the other things are same, that AB upon OB. Actually, the acceleration is AD upon OB, that is the acceleration, and the area of the trapezium is the this equation of uniformly accelerated motion. Actually, with certain velocity it was moving, and at a point it has accelerated, and the final velocity v. So, and this s is the distance. So we'll be finding out first equation of motion. Acceleration is equal to final velocity minus initial velocity divided by time taken. So a is equal to v minus u by t from the definition of acceleration. So if you cross multiply, you'll be finding v minus u is equal to at. Therefore v is equal to u plus at. That is the first equation of uniformly accelerated motion. Remember, it is a retarded one, so a can be replaced by minus a. Second equation, average velocity is initial velocity plus final velocity divided by 2. So v average is equal to u plus v by 2. Distance traveled is average velocity into time. So it will be s equal to v average into t divided by u plus v by 2 into t. So from the first equation, v plus u by u b equal to u plus at, you will be getting s equal to u plus substituting the value of v is u plus at divided by 2 into t. So you'll be getting s equal to twice ut plus at square by 2. So ultimately you'll be getting s equal to ut plus half at square. Once again, the same point. If it is a retarded motion, then a would be replaced by minus c. The second equation of motion. Third equation of motion. On the first equation of motion, v minus u equal to at. Second equation, v average equal to u plus v by t. So u plus v is equal to v average into 2. So what will be the value? V plus u is equal to 2 v average, and now simply multiplying v plus u into v minus u, a plus b into a minus b is equal to a square minus b square. So v square minus u square is equal to twice a t v. So v square minus is twice a s. You will be getting, so because v average into t is equal to s. So ultimately you will be getting the third equation, v square plus u square is plus twice as. For uniformly retarded motion, it will be a will be replaced by minus a. Equations of uniformly accelerated motion by graphical method. So just the same one, but the graphical method. A is equal to BD by AD. So check it out. V minus u is equal to AT. Plus u equal to AT. That is from the slope concept. And second equation is the area. Area of the trapezium is half into sum of the parallel sides OA plus CB into the distance between the two parallel sides, that is OC. Putting the value, you'll be getting is equal to u2 plus half at square. The third equation of motion, S equal to half into OC into, that is the area, V plus U is equal to twice S by T. Just a simple cross multiplication will give you, from the first equation of motion we have V minus U dt, multiplying equation, so what get V square minus U square is equal to twice AS. So V square is equal to U square plus twice. Uniform circular motion. Okay, I didn't take circular motion first. I've taken a rectangle, then a hexagonal, and maybe octagon, like this. I've taken some different, and the last one is a circle. Now when a body moves, say the green dot, it moves, so you can see after every side movement it has changed the direction. This one, you can see they're gradually approaching towards the circular path, so they are changing the direction at every instant, and so that you can see that is for the circle. And this one is a more complex direction. So now all moving together, how it moves like, you can see they are moving like this. So basically circular velocity is that one where it may remain like may travel through equal distance in equal instant of time, but its velocity changes direction at every instant. The motion of a body is circular or curved path is called circular angular curvilinear motion. It's a curvilinear motion. When the body moves in a circular path with uniform speed, its motion is called uniform circular motion. Note that the velocity changes at each and every instant, and hence the body experiences acceleration. Here R is the radius. So the velocity of the body at circular path, rather it's the speed of the body at circular path, is 2 pi R by T. So some examples of uniform circular motion. Artificial satellites move under uniform circular motion around the Earth. Not all artificial satellites, only the geosynchronous one. The moon moves in a uniform circular motion around the Earth. Sometimes it changes. Anyway, to great approximation, we can say the moon is also moving with uniform circular motion. The tip of a second's hand of a clock exhibits uniform circular motion. This is a perfect uniform circular motion. Second hand, minute hand, or hour hand, all. Well, I am thankful to Sri C. Moni sir for his PowerPoint presentation on the topic, which I have remodeled for this lesson, and also my acknowledgement to the objects body of like a red car, aeroplane, ship, moving earth, rotating earth, sun, galaxy are taken from the various websites, and that for that I'm thankful to Google. I'm also thankful to some of the websites like Colorado FAT for making us enabled with different